Hey all, welcome back to my channel Hayadari. In today's video, we are going to see something that's very much important when it comes to AI, data science, and machine learning. In the important topics of machine learning algorithms, now in today's video, we are going to see something called classification. So this is like a foundation when it comes to machine learning algorithms. So in this video, we're going to see about what is classification, what are the main types of classification algorithms that are being used in today's industry. Without any delay, let's get started. So first, let's try to understand what is classification. So the name itself could give you some idea on what is classification. So what it is? Absolutely, it's about classifying something. So it's about finding the differences and putting them into different classes based on the similarities or something. Let me give you one example. So if I have a picture of two different animals, like a dog and a cat, if I want to classify which is dog, which is cat, based on the features, like the size of the ear, the shape of the nose, the shape of the eyes, I will be giving all the details in table format, and finally I'm going to predict if it is dog or cat. Or I can even give it as image and I can predict if it is a dog or cat with the help of machine learning algorithm. Then those algorithms come under classification algorithm, because classification means predicting categories or labels. So let me give you some examples so it makes easier for you. In your mail account, if you have so many mails, you might have seen something called spam folder. You might have noticed all the advertisement based messages, promotion based messages are coming under this spam. But have you ever noticed how it is happening? What is the backend process? So that is the basic example for classification. So what's specifically happening here is, when it comes to a mail that you're receiving from a particular person or a company or business, there are some keywords, specifically an advertisement based keywords. If that is present inside a mail, then it is absolutely a spam, like offer, discount. So those keywords are advertisement based keywords. If you have a particular keyword under those offers, discounts or something, these keywords are clearly being observed by my ML algorithm, and it is classifying it into spam folder, and rest of the mails are coming under your primary mail. So this is the best example for spam and not spam. So this is the best example for classification. So this is the base of foundation. So other example could be pass or fail, cat or dog, as I already said, fraud or not fraud, how to detect if a contact number or the messages that you are receiving from Instagram is a fraud message or a genuine one. So based on the activities, so based on the messages that you receive, so you can detect it, right? So if I build an ML algorithm to do that, then it is a classification process when it comes to machine learning. So we do have regression as well. Then when to use classification algorithm specifically? When the target output will be having multiple columns. In that, I'm going to predict one column, right? If that one column, the target column is categorical, like spam or not spam, fraud or not fraud, likewise, then I'll be using classification. It might be a binary scenario, it might be a multi-class scenario. It might have just two categories or it might have three categories. If I'm predicting which fruits these images are, it might be apple, orange, strawberry or something. When I have different classes, that scenario also comes under classification. And specifically, these classification algorithms are supervised machine learning. Generally, in machine learning, we do have three different types. One is supervised, unsupervised, and reinforcement. Supervised means we clearly have the labels. When it comes to unsupervised, the labels are not there. The labels means the clear differences. So we'll let the machine to find the differences, the minute differences. When it comes to reinforcement learning, it is still the future. We are letting the machine to learn from reward and gifts that we are going to give as similar to human beings. So for present, we do have supervised and unsupervised. Supervised means we clearly give the differences. So with that label, it will be identified. But classification algorithm that we are learning is a supervised machine learning, which means it it will use a labeled data set. So inputs with known outcomes for training the model. That is called a supervised learning algorithm. Now, what are the applications of these algorithms? The main algorithm application is email filtering. If it is a spam or not spam, or what purpose of mail it is happening. It might be sometimes from a HR, recruitment based mail. Likewise, if I want to filter it based on categories, I could do with classification. The second application is image recognition, specifically finding if it is a dog or something else, which kind of image it is, classifying them. The third application could be medical imaging or diagnosis. If I have an image or a scanned document in my hand, if I want to find if that particular person is having a disease based on the scanned image, then I can do that with classification. The next application could be customer churn. The churn simply means if a particular customer is leaving a business at a particular time when they didn't expect how it is happening. We need to observe it and we need to stop, right? There are some common patterns that might be hidden inside that business data. So if I found them, I can clearly understand what is the reason why this churn is happening, why this customer is leaving my business. And I can do some precaution measures to stop them from leaving my business. So it could be helpful for my business growth and also it could avoid the loss. So that is how powerful is this classification algorithm. So in that we do have so many types, but there are some important types that's being used in industry nowadays. Let's see them one by one. The first type is logistic regression. So we'll see them in detail along with coding in a separate video, the main ones. Now we are going to see what is what and how it is being applied. So there's the first type called logistic regression. When the category is just twice, we just have two categories, then we'll go with logistic regression. Like it's email spam detection, like spam or not spam, disease prediction if that particular person is having disease or not, customer churn prediction. This customer might become a churn or not, fraud detection if it is a fraud message or a real message. Sentiment analysis if I have list of all reviews, if it is positive or negative or a neutral review based on the emotional words that is hidden in that text. So for all these applications, I could use logistic regression because it has two outputs specifically. So when it comes to binary classification with two outputs, and when the data set is small, I could go with logistic regression. Keep that in mind. The second type is support vector mission. In this type, it generally, the machine learning algorithm, it will create a hyperplane or a line or a boundary. So it generally separates the classes, the differences. After understanding the differences, it will separate them effectively. When I want some project like face recognition, text classification, handwriting recognition, cancer detection, image classification. So in these kind of projects, understanding the differences is not easy. So when I have an algorithm which can clearly separate them based on the minute differences, then I could go with support vector mission. This powerful algorithm has that ability to notice the minute differences. So that is why it creates a boundary that separates classes effectively. So it is quite better than logistic regression. Now we have such an amazing algorithm that's being used in industry. It is decision tree. So it is used for making a decision of classifying, but how it works, that matters here. It generally creates a tree-like structure to make decisions based on conditions. If I have multiple categories, so making a decision which category it belongs to becomes difficult. In that scenario, what I'll do is I'm going to create a tree-like structure. So each and every branches have the condition. So if this condition satisfies, comes under this branch. If not, go to second condition. If not, go to third condition. So in that way, if I'm approaching this, the differences could be observed clearly by my machine learning model and it can effectively classify them. So when I need clear differences and when I have multiple classes, the must algorithm that you could try is the best algorithm you could try is decision tree algorithm. The next one is advanced level of random forest. Here, a combination of decision tree would be there. So now, when I need random forest, then when classes are high and I have different classes, and also the differences is not clear, there are chances my machine learning model could wrongly understand my data and classify them in a wrong way. In that scenario, I'll be combining the multiple decision trees. I'll be combining multiple decision trees with the purpose of improving accuracy and also to avoid overfitting. So, overfitting means my data is something that my machine learning model should understand and my machine learning model should learn my data. Instead of it memorizes the data, the problem that we are going to face is when I give a new data, it will give me an output that we didn't even expect. So to avoid that problem, I'm going to use this random forest. So it will avoid the problem of overfitting and also it will be increasing my accuracy. So in scenarios like stock market prediction, so it is such a powerful application, right? It is a critical one too. And disease detection, it might cause a life. Recommendation systems, whatever you see in Netflix, Amazon, you are getting suggestions, right? Credit risk analysis. I can predict if my customer who is getting a loan could repay them back or not. It is a risk based one. And finally, weather forecasting. We have never seen any weather forecasting that we received accurately. Most of the time, if they say if it will rain today, we'll have a sunny weather. Right. So these are something we can't predict easily. We can't classify easily. So I am combining multiple decision trees to improve accuracy. It's never going to be 100%, but it could be better than what we did with just decision trees. So that is the power of random forest. The first algorithm that we are going to see is K nearest neighbors, KNN algorithm. Here it is used for classifying my data based on nearest neighboring data points. So which means my data would have similarities, right? So it could be grouped instead of classifying. So that is how this specific KNN algorithm works. So these algorithms have similar applications because it works based on nearest neighbor data points. Based on similarities, it is classified. So that's why we have applications like movie recommendation, image recognition, handwriting detection, customer segmentation, medical diagnosis. All these applications need something like it need to be classified based on similarities rather than differences. Based on similarities, if I could group them, one category could be grouped, another category could be grouped based on similarities. I can easily classify them. Right? So that's what this algorithm follows. But the one disadvantage is it is not capable of handling large data sets. The next powerful algorithm is Naive. It is something works based on probability, which we might have studied at our 9th standard and standard 11th standard. So probability means the possibility for this to happen. So here the possibility that this category my particular data could come under. So it works completely based on probability. So spam email filtering. There is a probability it might be a spam or not a spam. How I could find them based on keywords like if I have offers or discounts, it could be a spam. If I don't have them, it is definitely a primary mail. Like sentiment analysis, news classification, language detection, and fake news detection. So all these particular applications specifically expect something called text classification. So Naibase has the ability to understand text and classify them clearly. So it is probability based algorithm. So whenever I need an algorithm for classification, specifically in text classification, I'll go to Naive algorithm. That's why we do use them for the similar applications. The next algorithm we are going to see is gradient boosting. So it is specifically used for sequentially when it comes to sequential models, specifically for improving my prediction performance. When I have something that I need to follow in a step by step process, and then I need to classify, like sales. So I could predict, if I could predict tomorrow's sales exact value, if I want to predict what exactly could be sold, which kind of product could be sold, it is almost close to regression, but it is still a classification. In that, we have data which is sequential, but using that, we are going to predict a category. That is gradient boosting. So, sales prediction, fraud detection, customer churn prediction, search engine ranking, disease risk prediction. So, here in this particular algorithm, the features that we do have and the target we do have is different. The features we might have numerical values, but in target, it is going to be a classification value. So in that scenario, I'll be using gradient boosting. That is why it builds models sequentially to improve prediction performance. So next to next, it will be building models by itself to improve my accuracy. So that is called as gradient boosting algorithm. So that is why we do have some powerful application like sales prediction. If I could predict my sales, it is easy for me to improve my business. So business growth is going to be better than what we do expect. The next algorithm that we are going to see is XGBoost. It is specifically used for high speed and accuracy. When I want my algorithm to work in a high level, when I need an output of high accuracy, then my go-to algorithm is going to be XGBoost because it is actually an advanced boosting algorithm. So see the powerful applications of these XGBoost algorithms. Credit score prediction. I can predict the credit score of a person. So I can figure it out if they could repay the loan or not. It is a risk, high risk factor, right? Then I can predict if that particular banking or online transactions could be a fraud or not. Customer churn analysis, house price prediction, recommendation system. So all these applications are powerful ones. If my data is changing a bit or my accuracy is not up to the level, overall output could be messy. In that scenario, I'll be using XGBoost algorithm. The next powerful algorithm that we are going to see is AdaBoost. It is somewhat similar to XGBoost because it is a boosting algorithm, but it focuses more on the mistakes that my previous machine learning model made with the goal of improving my accuracy. So the powerful applications of these algorithm, this particular algorithm AdaBoost is face detection that you have in your mobile phone. It is having the ability to understand the clarity. I mean, the pixels, the minute differences. So that is why it is used for spam detection, customer classification, disease prediction, and fraud detection. So it is focusing more on the faults and mistakes that my previous model could make. So that is why it focuses more on previously misclassified data. So if I want to increase my accuracy, I will be using boosting algorithms. In that, this AdaBoost is specifically used for previously misclassified data. Now, if I need a model which need to think like a human being, that's where this algorithm gives the entry. Neural networks. It is actually a deep learning based classification model. It was inspired by human brain, but still it works completely differently because it is still a mathematical function, but it is a powerful algorithm because it has neurons which works in a way which could understand my data very clearly and process it more faster, much faster than other algorithms. That is why it's being used in today's advanced applications like speech recognitions in your ChatGPT, in your Gemini and something. Then image recognition, chatbots like ChatGPT, then self-driving cars where we see Tesla running so successfully, and medical image analysis. If I could just see the X-ray or MI scans to detect a disease, I made an algorithm to automate the process. Most of the process in hospitals could be automated, right? So that's how this particular powerful neural networks works when it comes to classification. It has so many advanced applications. and it needs so much of GPU, high power as well. But it is powerful. Now let's see the key differences. Logistic regression is for binary classification. You can even take screenshot this particular one. Let me even maximize it, even though it's recording. Yeah, you can take screenshot. SVM, support vector machine, is for high dimensional data. The differences is not obvious. Decision tree is for easy interpretation. Random forest is for better accuracy. K nearest neighbors, as I already mentioned, it's for small data sets. Neighbors for text classification. Gradient boosting is for high performance. XGBoost is for advanced ML computations because it is almost similar to gradient boosting. But when I should choose AdaBoost? When the learning improvement is not there or previously misclassified data and I need an improvement, then I could go with AdaBurst. And finally, we have neural networks. Why I need this? In today's advanced applications, when my data is not easy to understand and I need to work with complex deep learning tasks, I'll be using neural networks. So I believe you clearly understood all these classification algorithms, the main key differences, and what is classification. So bye for now. We'll meet you in next amazing video. Yeah.